Okay, we're going to look at June exam DBE June 2023. So the question is, a ball is dropped from rest from the top of a building which is 15.2 meters high. After the ball has fallen 3.2 meters, a second ball B is projected vertically upwards from the ground, and then after a while the two balls strike the ground at the same time. So meaning that ball A would have fallen to this point, and then once it gets to that point, ball B will be projected upwards, then maximum height, then it hits the ground, and then ball A will continue going down until it hits the ground. Okay, we are asked to ignore the effect of air resistance. Question number 3.1, define the term free fall. So free fall is the motion under the influence of gravitational force only. Okay, then next question, calculate the time taken for ball A to strike the ground. So you want to calculate the time for ball A to move from this point until it hits the ground. So in that case, for ball A, what do we have? We have the initial velocity because they told us that this thing is dropped, right? So VI is equal to 0. And then the displacement, because we are going all the way until we hit the ground, that is 15.2 meters. And then what else do we know? We're choosing down as positive, therefore acceleration is 9.8 meters per second squared. And then we are looking for the time. So the time is unknown. So question number 3.2.1, we go to the formula y is equal to VI times the time interval half times acceleration time interval squared. So that is 15.2 VI 0 times time, and then plus half times 9.8, and then the time interval squared. So that is 0. So we have 15.2. Half of 9.8 is 4.9, and then times squared. And then we divide both sides by 4.9, 4.9. And then we just get the square root of 15.2 over 4.9. That will give us the time. So in that case, we'll get 1.76 seconds. And then question number 3.2.2, calculate the magnitude of the velocity with which ball B was projected from the ground. So for ball B, we are looking for the initial velocity. What do we know about ball B? We know if we choose up as positive, we know that acceleration is negative 9.8, and then VI is unknown, time is unknown. We don't know the maximum height that ball B will reach. So instead, what we're going to do, we're going to try and work out the time it will take for ball B to hit the ground. So in order to get that, we know that ball B was thrown upwards after A has fallen 3.2 meters. So we have to work out how long did it take A to fall 3.2 meters. So let us do that. Let's focus on this portion. So we have the displacement, that is 3.2. We have A, which is 9.8. VI is still 0. And then time is what you are looking for. So we use the same formula. So Displacement is 3.2. VI is 0 times time, and then half of 9.8, and then time squared, which is 3.2. That is 0, 4.9 times squared. And then you divide by 4.9. And then to get the time, you're just going to do square root of 3.2 over 4.9. So that gives us 0.81. 0.81 seconds. Right. And then from there, to get the time it will take for ball P to hit the ground, is just going to be the time it will take A to hit the ground minus 0.81. So the time for P, the time is 1.76 minus 0.81, which will give us 0.95 seconds. So the 0.95 seconds, the motion from, is the time it will take for ball P to reach the maximum height and hit the ground. So we can actually focus on the upward motion only, because we'll know that the final velocity there is 0. Meaning that the time, using time symmetry, will divide by 2. Which means the time that we're going to use there will be 0.95 divided by 2. So 0.95 divided by 2, it gives us 0.475 seconds. And we know that for that motion, which is from here up to there, we are looking for VI, and then VF is equal to 0, and then we have the time. So we are looking for VI, acceleration obviously up is positive, that's negative 9.8. So we're just going to say VF is VI plus A times the time interval. So VF is 0, VI is unknown, A is negative 9.8 multiplied by the time, which is 0.475, which gives us 0 VI minus 9.8 by 0.475, that will be 4.66. You transpose VI is going to be 4.66 meters per second, and that is going upwards. So that will be the initial velocity of ball P. Okay, the last question. On the same system of axis, draw the position versus time graph to show the motions of both ball A and ball B from the instant ball A is dropped until it reaches the ground. So we'll do our position versus time graph. So that's position in meters, and then that is time in seconds. So we know that ball A will fall from 15.2 meters. So 15.2 meters until it hits the ground. You know that ball A will hit the ground after 1.76 seconds. And then ball B is going to be thrown upwards. But after how long? After 0.81 seconds. After 0.81 seconds. And then it will go up, reaches the certain height, and hit the ground at the same time as ball A. So that is ball B, that is ball A. Okay, so that's the end of that question.